Alright guys, I'm going to go over the Newton's method in MatLab. Hopefully the mic is not too loud, and hopefully you can see and the video quality is not terrible. So alright, here we go. If you haven't yet, go to the WebCT and you can find the Newton's method just that way, or you can pause the video right here and just copy it down if the quality, if you can read it. So I've already done that here, but if you haven't done it yet, I'll just minimize this. Go to File, New, Script, and after you copy that down, just paste it right here, and you can save it. I'm not going to save it, but because I already have it. But click Save here. All right. So in this problem 331 in the book, the maximum deflection is at where the derivative is equal to 0. The derivative of that large function up there, it gives it right there. So we're going to need to make a new function for it. So we're going to go back to New, Script, and we're just going to create a new function here. So this is going to be the first derivative in the Newton method. So let's just call it FunDer X. And I copied that already just to save some time. Those are the values given in the book. And then you can do it on paper, or you can just kind of do it in your head, whatever. It's pretty easy. So we're going to do the derivative of that function it gives us. So 120, or W over 120 times L times E times I, and all of that times 6 L to the third times X, and minus 21 times L to the second times X to the second, plus 20L times X to the third minus 5 times X to the fourth, and finish her up with a semicolon right there. So after you make your function, save it. Once again, I'm not going to save it because I already have one, but yeah. Alright, you can exit this. So hopefully you guys can still hear me. But so now we just use the function. We got the NewtonRoot, and I called my function. You're going to want to call it with the @ sign, but my function is called differently. Just whatever you made your function, call on it. So in this case, this is the first derivative. I'll create another. You're going to want to create another function that's the second derivative the same way, but here we go. I'll show you that right after this. And then you want, for the Newton method, you want the estimated x value, the error. I think it gives that in the book, yeah, 0.001, and then I'm gonna go with just 50 iterations, so we'll see what happens there. And yeah, that gives the answer. So I'll show you the second derivative if you want to see that. But you do that the same way. You just create a new function. You can pretty much copy the second, or the second line, make this function second derivative, whatever you want to call it, and just take the second derivative of this. Here it is right here, and yeah, you should get that answer. So hopefully this helped a little bit or something. And I'll do a video on the secant method here too. So see you in a minute.